Have you ever stopped to think how you're able to watch this video? Like, how did it get from some server somewhere in the world to your phone, your laptop, your smart TV? Because it's not magic, but it sure feels like it sometimes. Let's pull back the curtain and take a look. When you hit play on this video, you're not just talking to YouTube. You're talking to a physical server, a real computer sitting inside a massive data center, maybe thousands of kilometers away. Think of a data center like a giant warehouse full of supercomputers, all humming away, storing videos, apps, websites, everything. Now here's what most people ask, wait, can't we just beam all that data through satellites? And yeah, you could, but satellites are far, like over 35,000 kilometers up. That means every request would have to go up and back down. That's over 70,000 kilometers just to load a single video. You'd be waiting forever and a day. And that crazy distance, that's what causes latency, or in normal speak, buffering lag. That annoying spinning wheel that ruins your vibe. Instead, most of the internet runs through cables, but not just any cables, optical fiber cables, tiny strands of glass carrying beams of light. Literal light zipping your data around the world, under oceans, across countries, and yep, right under your feet. And they're fast. So whether you're using Wi-Fi, 5G, or plugging into your router, your device is tapping into this massive fiber network that connects, well, basically everything. Back in the data center, that video lives on a solid-state drive inside a server. When you hit play, your device basically says, "Hey, do you mind sending that video over?" And the server's like, "Yep, you got it." But how does your device know where to send that request? That's where IP addresses come in. Every device on the internet has one. It's like a digital street address. But come on, nobody wants to type in an IP just to watch cat videos. That's why we use names like YouTube.com, Facebook.com, and so on. Behind the scenes, your device asks a DNS server, "Hey, what's the address for YouTube.com?" And the DNS server replies, "Here you go. Use this IP." Now your device knows exactly where to go. Your request travels through fiber cables, hops through routers and switches, and eventually reaches the right server. But get this, YouTube doesn't always send it from the original server. Thanks to content delivery networks, there's a copy of that video stored on a server near you, maybe even in your city. Less distance equals faster streaming. The video isn't sent as one giant file. It's sliced into tiny chunks called packets. Each one carries a little piece of the video. These packets are like little data cars. They don't all take the same road, each finds its own fastest route. But when they arrive at your device, they get reassembled like puzzle pieces. Boom, there's your video. And if a packet gets lost or delayed, no stress, your device just says, "Hey, I'm missing this bit, can you resend it?" And the server's like, "Yep, here it is. Easy." All of this happens because of protocols, sets of rules that keep everything working smoothly. They define how packets are sent, received, and double-checked. We'll break down stuff like TCP, UDP, and ports in future videos. So let's zoom out, you press play, your device finds the server using DNS. Your request zips across a global fiber network. Packets get sent back, travel across the world, and get stitched together on your screen. And it all happens in a blink, which is pretty wild. This is the big picture of how the internet gets your video from a data center to your screen. But behind the scenes, there's even more going on: routing protocols, encryption, address translation, and more. We'll cover all that in future videos, so if you thought this was cool, then you're definitely in for a treat because we're only getting started. So stick around, hit that like button, and subscribe.